nitrogen can be a little bit difficult to determine what its hybridization is because of the presence of a lone pair. See, bonds are somewhat fixed. A sigma bond needs a hybrid orbital. A pi bond needs a p orbital. What makes nitrogen so difficult is the lone pair. It can be either in a p orbital or in a hybrid orbital. So to determine which one it goes to, you have to first of all take a look at what you know and use that to eliminate one of the three possibilities. And then you look and decide what does a lone pair would rather be in. So let's go over the three types of hybridization. We have sp3 hybridization, which means you have 4 sp3 orbitals. sp2 means you have 3 sp2s and 1 p. sp has 2 sp orbitals and 2 p's. And so sp3 can form 4 sigma bonds. sp2, because it has 3 hybrid orbitals, it can form up to 3 sigma bonds. And sp has 2 hybrid orbitals, it can form 2 sigma bonds. So let's take a look at this molecule right here. It has 3 nitrogens on it. I'll label this one A, B, and the bottom one C. Let's take a look at nitrogen A first. Nitrogen A has 2 sigma bonds. And 1 pi bond. So therefore, the possibilities are it can be sp2 hybridized, or it can be sp hybridized. Because sp2 hybridized has 3 sp2 orbitals, so 2 of them can be taken in place of the 2 sigma bonds, and then it has a p orbital for the pi bond. Or if it's sp hybridized, the 2 sigma bonds take the 2 hybrid orbitals, the pi bond takes the p orbital, and then the lone pair takes the remaining p orbital. So you have 2 different options right here. sp3, in this case, is not an option because there's a pi bond. Because you have a pi bond present, you need to have a p orbital. sp3, no p orbitals. So we've narrowed it down to either sp2 or sp. When we're trying to decide between sp2 and sp, we have to think about the geometry of that. Is that geometry, is that angle around that nitrogen, is it going to be 180 degrees, in which case it'd be sp, or is it more 120 degrees, in which case it's sp2? Sometimes the model helps, but if you look here, it would be very difficult to draw a hexagon with a linear 180 degree bond angle. This bond angle is closer to 120 degrees. So this nitrogen A, is sp2 hybridized. it has two sigma bonds. So that takes care of one sp2. One sp2 has the pi bond, which takes care of the p. Therefore, its remaining lone pair is in an sp2 orbital. Okay. Now, let's take a look at nitrogen B. Nitrogen B, right here, has three sigma bonds to it, meaning that it needs to have at least 3 hybrid orbitals. So the only two options that have at least 3 hybrid orbitals are sp3 hybridized or sp2 hybridized. Trying to decide between these two is not a case of thinking about simple geometry. In this case, what we have to think about is looking at what these sigma bonds are to. In most of the cases, if that nitrogen is bonded to an atom with a p orbital, then that lone pair will also want to be in a p orbital. So if we take a look at nitrogen B, it's attached to a hydrogen. That hydrogen only has an s orbital. This carbon right here is sp3 hybridized. So it doesn't have a p orbital. This carbon right here is sp2 hybridized. It does have a p orbital. Because this carbon has a p orbital, that nitrogen lone pair wants to be in a p orbital. So therefore, nitrogen B is sp2 hybridized to allow that lone pair to be in a p orbital. If we take a look at nitrogen C, nitrogen C again has 3 sigma bonds, meaning it can be sp3 hybridized or it could be sp2 hybridized. If we look at this, these two hydrogens, neither one of them has a p orbital. Both of them are s orbitals, so that doesn't help. This carbon right here is sp3 hybridized. It has 4 sigma bonds, and so it doesn't have a p orbital. So none of the substituents that nitrogen is attached to has a p orbital. So therefore, this lone pair will opt to stay in an sp3 orbital. So, to recap, nitrogen A is sp2 hybridized. Its lone pair is in an sp2 orbital. And you use geometry to determine whether it's sp2 or sp. Nitrogen B is also sp2 hybridized. Its lone pair is in a p orbital. Nitrogen C is sp3 hybridized. Its lone pair is in an sp3 orbital. And what differentiates nitrogen B from nitrogen C is the presence of an adjacent atom with a p orbital, like so.